Hello, biochem students. So we have a activity on protein structure. Well, actually, we have several. One was on primary protein structure and amino acids. This video is on secondary structure of proteins. And there's two main types. There's the first type that was discovered by Linus Pauling, and it's called the alpha. And the second one that was discovered by Linus Pauling, it's called the beta. So, A is first, B is second, alpha, beta. The first type that he discovered are helical. The second type he called beta structures. These are beta strands or beta sheets, and oftentimes they're called beta pleated sheets. Let's focus on the alpha helix. So this is on page 54 of your book, and you can see that there's a helical structure here. And in this picture, it's only showing the alpha carbons and the R groups that are on the alpha carbons. So you remember that the amino acid has an N, the amino terminal, the alpha carbon, and then the carbonyl carbon. So let's draw those in so you can see how they go on here. So the alpha carbon here is connected to a nitrogen, and it's also connected to a C double bond O. And then that's the NCC. So this is the first R group, the first amino acid. The second one would be over here. The third one is in back. We can hardly see it. The fourth one is over to the right. Fifth one is here, 6, etc. So I've got one amino acid drawn. I'm going to draw the next one. So this is the alpha carbon, has the R group, the second R group on it. It also has an N, and it has the C double bond O. Okay, so there's the second amino acid. Now, how are they joined? They are joined by the peptide bond. I'm going to put the peptide bond in green, I guess. So here's a green peptide bond. And you know that that nitrogen also has a hydrogen on it. Now the hydrogen is trans to the C double bond O. And why do I say trans? It looks trans. So here's another cool thing. I'll use blue. Okay, see this lone pair right here on the nitrogen? There's a resonance structure where that lone pair goes to make a double bond. The peptide has double bond character, and these electrons go up to put a negative charge on the oxygen. So there's two resonance structures, and I don't think I can draw them. Okay. Can't draw outside of this white box. So you need to remember that the peptide bond has double bond character, and the NH and the C double bond O form a 4-atom, the HNCO, plane. All 4 atoms are in the same plane, so you can think of them as flat. Interesting. Now, yes, it's flat, and the bonds around it, the bonds around it are free to rotate. So let's try that again. Okay, so this one's free to rotate, and this one's free to rotate. They're not completely, they're single bonds, so they're free to rotate, but not completely free to rotate. And depending on how big this R group is, they may have a preferred orientation. Okay, let's get back to our alpha helix. Because of these free to rotate, the alpha carbon to N and the alpha carbon to C, how would they form themselves so they're not just random? So hydrogen bonding can hold them into a specific structure, the secondary structure, the alpha helix. It turns out that the alpha helix is held together by hydrogen bonding between the C double bond O and the NH of the amino acid plus 4. So if we start with this C double bond O here, which is on the first amino acid, if we count plus 1 plus 4, we get to the 5th amino acid. So let's draw in the NCC around that one. So here's the alpha carbon. So there's the N, and there's the alpha carbon, and here's a C. And this C is going to have a double bond O, similar to the first one. And I need the peptide bond to the next one. Here's an N. Here's the alpha carbon. And then we can't see the C double bond O. It's wrapped behind. So what about the peptide bond? It's right here. And the N, let's see, make this black. This N is going to be this way. Or is it going to be the other way? I think it's the other way. This N is going to be this way. So we've got the C double bond O of the first amino acid and the NH2, the NH of the 5th amino acid. And we have a hydrogen bond here. So here's the NH of the 5th amino acid. Here's amino acid 5 with the 5, R group is 5. And up here we have the amino acid 1 with the 1 R group on it, R group number 1. And notice that there's this hydrogen bond between the carboxyl group of 1 and the NH of the 5th one. And if we look at the next figure, you can see these. So here's the NCC, and here's an NH, and here's the hydrogen bond between them. And this is the 5th, and this is the 1st. Oh wait, that was the 4th. This is the 5th. And notice here's some more. Here's the C double bond O and the NH. Here's another one, the NH with the C double bond O. Here's another one, the C double bond O with the NH. Here's another one, the C double bond O with the NH. Notice that all of these hydrogen bonds are parallel to the axis of this alpha helix. Here's another picture where we're looking down the axis. So the axis is there, and notice that the R groups are all out to the side. They're sticking, whoops, don't need the keyboard. Not sure what I have done here. Okay, wait, here we go. So the R groups are out to the side, and sorry about this. I'm not sure why it's. And you can see the N's and you can see the O's, but which way can you see any of the hydrogen bonds? No, because they're parallel to the axis, so we can't see them in this picture, but we can certainly see the R groups all sticking out to the side. And I was thinking that I had one more picture here to share with you, but maybe not. In the last picture, if you look on page 54, part D shows the van der Waals spacefill view. And in that view, you can see that you cannot see down the middle of the axis of the alpha helix. It's tight. There's no space in between. This C, model C in figure 4.11, looks like there's space there down the middle of the axis, but there's really not. And if you look at picture D, you can see that. All right, so this is the end of what I'm going to tell you about the alpha helix. What are some things we should know? What maybe we should recap. Alpha helix. H bonds between the C double bond O and the NH of the backbone of the primary structure fold into the alpha helix. All right, great. The next video will be about beta pleated sheets.